Okay, just a video just to cover why English is bad for science. Now, first of all, good side of this is you'll be smarter than everyone else. You'll be really good at science. The bad news is science always looks for errors and it's terrible for people skills. So it's great for nature of science. It's absolutely terrible for nature of humans because humans do not want to be told they're wrong. And if you're very successful in leadership, you're probably good at, no matter how bad it is, you need to say how good it is, which is the complete opposite of science. No matter how good it is, we're trying to work out how bad it is. And so there's an issue there that I'm not going to deal with because I'm just trying to make you good at science. Uh, Chances are it'll make you bad at relationships. But that's for you to deal with and manage. All right. So, first of all, just to let you understand, my focus here is just to make you good at science. Why English is so bad for science. And I've just put four examples down because they're sort of recent. And I won't go into any more because it'll go too long. So the first one is um, a student actually understanding the science and so actually picking up PhD experienced teachers and how they're wrong because we have this tendency just to look at the English and not see past it. And so he was presented with a word that was exothermic, and then you're expected to do a test and answer that question. But because he understood enthalpy and he understood the concepts of how the reaction worked, he actually realized that the reaction was in the wrong direction. It was actually endo or vice versa, because exo and endothermic are competing forces uh, in equilibrium reactions. So he was thinking past the English to look at how the forces were actually working, and he actually picked up an error in a PhD um, teacher. All right. Recently, I've also had another student pick up errors even in the textbook. Most people just look at atomic size and ionic size and think, oh, that's how big the atom is. But he was looking at the actual sizes of the forces and realized that there was a huge inconsistency in a trend. And the reason for that was because ionic size and atomic size isn't really ionic size and atomic size. They do an experiment to measure the distances between two elements and there's heaps of issues with that. And that's why there are mistakes in the data booklet that you're not to question. And so once again, he was seeing past the English and looking at the forces involved. And so and also the experimental technique. Um, and so he was able to understand that it's wrong. Recently, the last video, if you look at the last video that I just did there, um, you have to do what people want. So you have to say like dissolves like as your reason, which isn't really a reason. It's sort of like an acronym or something or a little trick, sort of like something else I try not to remember. I think it's um, cat or Leon goes grr or something for redox reactions. Try and block that out of my head because that prevents you. That's putting English in front of scientific evidence. And so you shouldn't really think of things. You might have to say like dissolves like, but never really think that way. Always think of the forces involved, positive attracted to negative, because like dissolves like, it's a simplification that's not going to cover every single situation that occurs in this world we live in. And so that's just a preemptive. Recently, I realized that IB was teaching. This is IB we're talking about. We're talking about a huge community of PhD scientists and professors, etc., that they are actually teaching chemical reactivity wrong. They were saying it's because of positive induction. Now, the terms are very confusing, and people are it's actually negative induction, and they realize it's hyperconjugation, but it's not the English words. They're just complicated screens to stop you understanding science. The way I found that out was just because I was looking at the positive and negative forces, and it made absolutely no sense. It was the complete opposite. It's actually negative, not positive. But that's another example of everyone just hiding behind these words and not looking at the actual forces involved. So I think it goes that deep. All right, it goes to students correcting PhD people. I've corrected many PhDs over my life because of that very thing. Because they've used a word and they haven't actually looked at the data and the evidence that's behind it and the forces involved. And so you've got to look on a realistic level, which is the universe doesn't care about English, it just cares about the sizes of the forces. And that's how you need to think. It may be different how you answer on an exam, but to actually understand, you need to do that. And you'll find out there's so many mistakes all over the place. So I'm suggesting that we do the opposite of what I think most curriculums are trying to do, which is put lots of English in there. You really need to pull away as much English as you can. And you really need to talk about the experiments and the data. So how does the evidence support that theory and where are the flaws in that? And how we test as well. Instead of using that English, we need to test for how do you know that experiment evidence supports that idea. And then you'll be smarter than your PhD professors and teachers and the textbook, and certainly AI, because AI is language based and not mathematical data based. And so that's why I bag English so much, because um, it's a complete shut off to being able to properly understand science.